let's basically just get to understand how we get to graph our trigonometric functions as simple as possible. Okay, so this is our graph. This is what we have as our xy plane, and then of course we need to understand the basic forms of our different trigonometric functions. So to start with, we're going to first of all look at the sine graph. Okay, so how does a basic sine graph come out on a graph? So if you get to graph the basic sine function, you do know that it's going to be something that is going to come out like this. Okay, and then it gets to end there. Okay, that's the basic form of the sine graph. And of course, we do expect that this is going to be 90, which is pi over 2 in radians. This is pi over 2, and then this is our pi, and this is 3 pi over 2, which is 270, and then finally we have 2 pi, which is like 360 in degrees. So this is a basic form of our sine graph. Okay, so if you know the basic form of a graph, it's going to be very easy for you to sketch a graph. Okay, whether we've added things like the amplitude, the phase shift, the vertical shift, all these things are just going to have a slight effect on the basic form of a function. For example, what if we try to say sketch sine? Okay, let me start with 4 sine, and then I'll say 4 sine x. So what you need to understand is the 4 that is indicated there is what we call the amplitude. So basically the amplitude tells us how high the graph is going to go and how low it's going to go. So of course in this case I needed to indicate that it was going to be a 1 and also a negative 1 to be our minimum y value. Why? Because the basic form of a function just has a 1 there. So in a case where we get to have a 4, what is going to be easy? We can just, no need of us even getting to worry about that. We can just change here and then show to say we have positive 4 and also a minus 4. So we now understand the effect of the amplitude on our graph. What about if we try to change something else? Let's say if we said we have 4 sine and then 2x. So now you understand that this is 2x and then that is x. So this takes us to a new effect, which is we are calling the period. Okay, so the period is also one of the things that gets to affect the basic function. And how does the period affect? So it's denoted by capital letter T, and of course it's dependent on the coefficient of x. Okay, so in this case we have a 2. So the period is basically determined or calculated using this formula where we say our period is equal to, so say 2 pi divided by the value, of course the absolute value of b, which is the coefficient of our x. So in this case, in the initial form, we just add a value of a 1 being the coefficient of x. Okay, so therefore our period is just 2 pi, and of course we do understand what the period is. This is like how long it's going to take to complete a revolution. So if we are starting at this point, how long is it going to, like in terms of the x-axis, we need to complete a full cycle. Okay, so we need to have the crescent as well as, so we need to have the top part as well as the bottom part. Okay, so and then we are going to get to the initial point. That is what we're calling the period. So from this point where we're starting up to the ending point for a complete wave, full wave, that's what we're calling our period. Okay, now what happens if we have a value of 2, like in this other case where we're saying 4 sine 2x? So that would mean that we, in our calculation there, we would need to divide by a 2. So if you divide by a 2, what do you expect to have? You're basically going to have pi, which tells us to say that we need to have a complete revolution within pi. So therefore, if we sketch our graph on this same scale that we have, what we need to expect is we need to have something that is going to come out like this. Okay, so it would have to come out like this. Okay, so the basic idea is what we are noticing is there's a complete revolution within just what? A pi. And of course that's what it means. But to make things easier, what we can do is we can do this. I'll erase everything and then we'll just try to make it smoother. Okay, so this is our graph. So the only basic idea is, since our period in this case from this graph is giving us a pi, we can just make our lives easy by just what? By just of course drawing the function itself, of which we do know is this is the way it's going to come out, the normal way. Okay, now since we know that our period in this case is pi, instead of putting 2 pi at the end as we do for the basic form, it's going to change. We'll just change and put what? We'll just put our pi there. Okay, so we know this is the middle point. So what's the half of pi? It's going to be pi over 2. And then of course, what's the half of pi? Pi over 2. It's going to be pi over 4. Not so. And then of course, you need to find the middle part between pi over 2 and also pi. So pi over 2 plus pi. This is obviously going to give us so that is going to be 3 pi over 2, and then if you get to divide it by 2, it's going to give us 3 pi over 4. Okay, so this is basically what we have on our graph. Okay, so that is the effect of the period on the graph. It basically changes the complete revolution where it's going to end on our x-axis in terms of angles. Okay, so we now know the effect of the amplitude as well as the period on our graph. Okay, what if we tried to add something new? Let's say the way the graph is 4 sine to x, and then what if I get to, let's say, maybe add something, maybe add pi. Okay, how do you expect this to be different? And of course, to just make it interesting, I can put this in brackets, and then let's say that's what we have. So the pi that we're seeing there is what we get to call phase shift. Okay, so we now have, first of all, we do have the basic form of that graph. Of course, looking at it in the case where it is having a period of a pi, I'll not alter anything, I'll leave it the way it is. Let's try to understand the way the phase shift is going to affect this graph that we already have. Okay, so the phase shift basically shifts the graph along the x-axis. Okay, and of course, every time you have that form, you need to make sure that every time you're trying to sketch a graph, you need to have the 2 factorized. It should be outside the brackets. So therefore, if I get to factorize out my 2 there, what I expect to have is our 4 sine, and then the 2 is going to be outside, and then I'll remain with x. And of course, from our factorization, we are taught to say that it will become pi over 2. The basic idea is if you get to distribute the 2 inside the brackets, you should be able to get what you had initially. And of course, if you multiply 2 by pi over 2, you expect to go back to the original form, which is going to be 2x plus pi in the brackets. Okay, so this is the value of A, that's our value of B, and then that is now our value of C. So the value of A helps us to determine our I, which is the amplitude, and how low it's going to be, as we can see on our graph. And then the value of B helps us to determine the period, which is telling us the angles that is going to take for it to complete a wave. And then of course, C is giving us a phase shift and how we are going to shift along the x-axis. And of course, every time it's positive in the brackets, what we need to expect is it's supposed to go towards the left hand side, and it's negative, supposed to shift towards the right hand side. So in this case where it is positive, or if you don't want to master that, what you can just do is always just equate what is in brackets to 0. So it's basically going to be our x being equal to negative pi over 2 if you equate what is in the brackets to 0. So therefore, that basically signifies or indicates to us that we're supposed to shift towards the negative by a magnitude of what? Pi over 2. So each point that we are seeing on the graph I'm now free to erase this for a moment. And then of course just take note that our graph is now 4 sine, you can just write that 4 sine 2x, sorry, supposed to factorize it 2, so that is x minus plus pi over 2. Okay, that's our graph that we have in the simplified form. And of course what we are saying is, if this is a phase shift, that is our phase shift, so our graph is expected to move towards the left hand side. So this point is supposed to move by a magnitude of what? Pi over 2 to the left. So I'll just indicate using the scale that we have. So of course it's going to be pi over 4, and then that is going to be like pi over 2, and of course these are negative values, so I'll put negatives. So therefore this point will now shift to that point, and then of course whichever point, that point will also have to shift by negative pi over 2. And the easiest way of you doing that is if you look at the way I've used the scale that we have, depending on the graph that we have, this point has moved like 1, 2, so it's just skipped 1 point. So even this one will just have to skip 1 point so that it will go to this point. And then this point also just skip 1 so that it will come now to this point. And then this point will also just have to skip 1 point. So if it skips this one, it will now be at this point. Okay. And then of course the last one will also just skip 1 and then get to this point. So if we get to sketch the new graph, it's going to be something that is going to come out like this. So this is the confusion that we have. Let's try to see how we'll move this. Okay, this is something that, okay, so I'll draw that again, and then passes there, then there. So we can even continue. We've seen the way it's moving, so it will have to move again to that point, and then finally it gets to that point. Okay, so that is the way you need to understand that. That's the way phase shift is going to affect our graph. And of course, if it is, we are specifying the domain. If you've discredited the negative part, you can just put dotted this side so that you show that the actual graph is starting from 0. But for the sake of helping you to sketch it, you can just show it to see the way. Okay, this is the way the graph has moved, but what you need is just this part. Okay, so we'll specify, of course, the domain that they're interested in, but basically that's how we can talk about the effect of the phase shift on our graph. Okay, so we now understand the effect of the phase shift on graphs. Now we also need to understand the effect of the vertical shift. Okay, so going back to the basic form of our equation, where we said y is equal to sine x. This was the basic form of the equation. Okay, from there we had to understand the effect of the amplitude, where we said this is going to be 4 sine of what? 4 sine x. So what did we see? So if I go back to the graph, let's go back to the graph. So this was our graph. Okay, so we saw to say whenever we are talking about the sine graph, something that is going to come out like this. Okay, that is the basic form of the graph. So the amplitude had to change the value from a 1 to 4, minus 4. That was the effect of the amplitude. And then of course, in the normal case, we do expect the basic form of the graph to have a period of what? To have a period of 2 pi. But again, after changing the coefficient of x, where we say 4 sine 2x, we saw to say these two as an effect on the period, which would determine where the graph is going to end. And of course, in this case, you have to be pi. Okay. So of course, it doesn't necessarily mean that you're supposed to end on the period, but what it tells you is, it tells you to say within that's where you expect the graph to be complete. So there may be some cases where you have a period of pi, as we can see in this case, and then of course they tell you to say you need to draw from from 0 all the way up to 2 pi. So in that case, that would mean you need to have two complete waves made. What's that supposed to mean? What it means is this. So you're moving from 0, and then of course, let's say you consider the last part to be 2 pi, and then your period is like pi, not so. So what you'd expect in that case is you need to have a graph that is going to be something like this. So this means you have a full form of a graph, two of them formed. So there is this one, complete within a pi. So we'll call the middle part to be our pi. So that's like our pi. And then again from pi to 2 pi, there's also another complete wave, starting at this point and ending at that point. So that is the basic idea of the effect of the period on the graph. We've also talked about the effect of the phase shift, where we said if let's say you have minus pi over 2, or let's say positive, when it's positive it's supposed to move towards the left. So each point is supposed to move by that very magnitude shown. Okay, so it will move, each point will move, and then you need to draw the new graph just that way. And then now let's try to understand now the effect of what we're calling the vertical shift. So I'll write the same form of our equation that we've been talking about, and then I'll of course work with x, that's a period of 2 pi, and then we'll say, let's say we had 4 sine x, and then let's say we had plus 2. Okay, so I've made it easy so that we just get to see what's going to happen. This is a basic form of equation. It can also be negative. Okay, so what's the main idea there? And of course, I can even add it this side so that you are not confused with the phase shift. So this is a vertical shift. This one gets to affect the y-axis, just like you might guess. Okay, so looking at the graph, so of course if you look at our basic form of the graph that we have in this case, I'll draw it. Okay, so the amplitude is basically 4, so I'll put a 4 and also minus 4 there. And then of course our period is 2 pi because value of the coefficient of x is a 1, so we're ending at 2 pi. So this is our pi, this is like pi over 2, and then this is like 3 pi over 2. Okay, what are we trying to say? What is going to be the effect of the 2 there? So just like we are coding it, we're coding it the vertical shift. So it's going to shift the graph in terms of the y-axis. Okay, so each point is going to go up by 2. So if you want to make things easier again, you can just start moving each point by 2. So if this is 0, of course, if you move it by 2, where do you expect it to go? To go to 2. So now that has moved to 2. You can move this point as well by 2, it will go to 6. You can move this point as well by 2, it will go to 2. This point by 2, it will go to minus 2. And then the last point from 0 as well, it will go at that point. So if you get to join all these points, this is basically what you're going to have. Something like this. And then, so what have we noticed? So each point has gone up by 2 because of the vertical shift. So it's also possible that this can be a negative, which will tell us to say all the values in the y are going to reduce by 2. Okay. So now, if you don't want to do that kind of shifting, what you can do is just move the 0 line to what? To the actual vertical shift that you have. So if you have a 2 being your vertical shift, what you can just do is just let 2 be what? The 0 line. That's all. If you consider that one to be the 0 line, you come up with the same graph. How? You consider the amplitude of 4. So if you're at 2 as your 0 line, and then you had a 4, which is the amplitude in this case, it will give us a maximum of 6. And then if you subtract by 4, it will give you a minimum of what? A minus 2. So you'll be able to say, okay, so considering 2 to be my zero line, my maximum value is going to be a 6, my minimum value is going to be a minus 2, and then you just draw the basic form of the equation. Those are the two ways in which you can get to show the effect of the vertical shift on our graph. Okay, so now let's try to proceed and then talk about the cosine function. So what is a cosine function? So even just maybe before we get to talk about the cosine function, I think I'll just need to mention one thing about the sine function. What if in a case we give you negative sine of x? Do you expect it to be in the same form? Of course, the basic form of our positive sine function, just like we had shown, this is going to be something that is going to come out this way. Let me draw something bigger. So this is the positive sine graph. Okay, so positive sine graph, sine x, and then of course in this case we have 2 pi as our period. That is like pi. I think these points are enough, and then of course we have 1 and also a minus 1 as our amplitude. Now what about if we said negative sine of x? And of course these values can be determined on your calculator. If you are even allowed to use calculator, it's even easy as well. So all you can do is, if you try, of course this is pi over 2, your calculator is supposed to be in radians, of course. Okay, so that is pi over 2, and then this is like 3 pi over 2. So in degrees, of course, this is 90, that is 180, that is 270, and then that is like 360. You can also use those values depending on what you are using on a calculator. Okay, so now what happens if you get to say negative sine of that? So remember, this negative is going to affect the value of y, and what it tells you to say all the values that you have for the sine graph are supposed to be regarded as negatives. So that is going to be more like a reflection. Every positive value is going to become a negative, so only the zero line is going to be maintained, and therefore this positive value, because of a minus that is there, is going to be reflected to the negative part. Zero values will not change, and then of course this is a negative, so if we multiply by a negative it will become a positive. So these are the 2 points that are going to shift, and therefore that's why the negative sine graph is something that is faces like that. Okay, it is kind of a reflection of the actual graph. So for it, it's going to, instead of starting upward like this, is to start from the bottom and then end with the top part. This is what we call the negative sine graph. And of course, in a case where they get to put things like minus 4 sine x, all the same, all the things are going to apply, but just know that instead of starting with the top part, you start with the bottom part. And that is how the negative sine graph is different from the actual positive sine graph. Okay, so of course also we need to understand now the cosine graph. So how do you basically show the basic cosine graph? So our cosine graph, let me just draw. So our cosine graph is something that is going to come out like this. So it has to start from that point. Maybe let me draw something better. Okay, I think that's better. So, and then this is too small. I can do this. Then I can sketch. Then I can put something like this. Then I can put it there. Then I'll put it there. Okay, now I can now draw. So remember, this is not a line, it's like it's supposed to be curved. So that is the basic form of a cosine graph. So if we're saying this is the basic form of a cosine graph, of course we are considering cosine of x. So considering the cosine of x, we are starting at also the amplitude over 1. So everything else relating to the amplitude, the phase shift, the vertical shift remains the same. All what is important is for you to understand the basic form of the graph. So of course this is going to be our pi. This is like pi over 2. That is like 3 pi over 2. And of course the last part is 2 pi. So this is the way the cosine graph comes out. And of course if you talk about the negative form of it as well, you expect that it will behave more like a refraction. So that it starts from the bottom part and then ends at that point and then it gets to come down again. Okay, this one is the negative cosine graph. So just you knowing the basic form of the graph will allow you to basically apply the effects of the amplitude, the phase shift, the vertical shift, and also the period. Okay, so what happens if we get to consider cosine of 2x? So you feel free to try that one out from the basic understanding of what the period is. So of course we said our period is going to be dependent, and also to make it interesting I can also add an amplitude of 2, so that we have 2 cosine 2x. So our period is basically expected to be 2 pi divided by the value of our b, which is the coefficient of x. Okay, so this is going to be what? Going to be pi. So going to our graph, okay, so what I told you to say is what you can just do is just consider the basic form. Just draw it, just draw the shape of the graph itself. So this is the expected form of the graph. So all you can just change is let the ending point be what? Be pi. That's all. And then you can divide it into half, which is going to give you pi over 2. Divide pi over 2 into half, give you pi over 4. And then this is of course going to be 3 pi over 4. Okay, at that point. So that's how you sketch it. And then if I've told you to say it's a graph that you expect to end at 2 pi, you can extend it, of course. You can extend it. How do you get to extend it? So it will continue moving just as it is. So look at the way it is. Look at the way it's behaving. So you expect it to go down. This side you expect it to go down as well. Because one thing that you're noticing is the fact that this is basically our amplitude. Okay, so in this case the value is what? It's a positive 2, and then on the bottom it's a minus 2. Okay, so that is the way you expect this graph to basically behave as a cosine graph. And in the case where you have a negative, if we had a negative all that, or what is going to be different is going to start something like that. So let me put this point there. I mean, to just be something like this. Yeah. So it can be, it will continue moving like that. Yeah, so it will behave depending on the way it has started moving. And that's the basic idea of this graph. Okay, so I think this point we can make it better if you want it to, yeah, if you are continuing up to the point where we say 2 pi, you have to extend it more curved. Okay, anyway, so what is the basic form of the cosine function, and that's how it gets to work. So of course with the additions of multiple things, it will make more sense when you have a phase shift, vertical shift. All those things are going to apply the same way we talked about the sine graph. Okay, so I think this is where we get to end in this video, and of course feel free to register using the link below to access the solutions to those different graphs that are shown in the tutorial sheet for Math 1100, Math 1120. Okay, you'll be able to access those solutions. So I just basically hope that you now have a basic understanding on how to go about the graphing of trigonometric functions. You have a lovely day.